I, Dr. Assan Jaye.
I, Dr. Assan Jaye,
Do swear.
do swear that
I'll speak the truth. I'll speak the truth.
I'll speak the truth,
The whole truth.
the whole truth,
And nothing but the truth.
and nothing but the truth.
So help me God.
So help me God.
Thank you.
Dr. Jaye, welcome to the TRRC.
To be here.
Thank you very much for your willingness to appear and testify before this commission. Dr. Jaye, I just want to give you a brief resume of what I expect our conversation today to entail. First of all, we would like to briefly talk about your biography, your work experience, places you've worked, your academic qualifications, your work on the area of HIV/AIDS and your publications. And then we would talk about your work on HIV and AIDS in the Gambia, how HIV/AIDS treatment was approached and dealt with by the MRC in collaboration with the Gambia government. We would also want you to talk about briefly the history of and the discovery of HIV/AIDS, how it was treated in Gambia in 1983, the history of drug discovery of HIV/AIDS, how it was hitherto a death sentence, the discovery of medicines such as lamudavine or zidovudine, excuse me, and lamivudine and all these Dean family, pretty much, the monotherapy drugs, and the move to other more effective drugs such as Combivir or the cocktails as some would call it. The result of those types of therapy and how ultimately HIV/AIDS moved from a death sentence to a manageable disease like diabetes and others, especially with the new interventions such as the heart treatment, the expenses involved in accessing treatment and how that was solved in Gambia, the initiation of heart treatment in Gambia and some of the ethical issues or some of the protocols that you had to observe, such as counseling, adherence, social and nutritional support, and all that issues of opportunistic interventions or infections, baseline surveys you would have had to do, and all these things, and how that has led to the results that were registered on HIV treatment in Gambia, especially looking at the cohort of 1,600 HIV-infected persons you worked with in 2005. And what happened when President Jaye suddenly appeared with a bag of herbs and made his breakthrough pronouncement, how that has affected HIV treatment in the Gambia. But centrally, the criminality in all that conduct, if you would call it as such. You are the expert. We would want to hear from you on that. The impact of Jaye's claim on the Global Fund and its use in Gambia. We would also want to understand a few things about HIV treatment. The differences between HIV-1 and HIV-2, and how, which one was prevalent in the Gambia and how these things were being dealt with. Basically, these are the things we would want to discuss. How Jaye's claim has affected the cohort you had at the MRC, the HIV clinic that you had, and how your activities had to move to Senegal, and your own assessment of the PATP. These are the issues I'd like to discuss with you. Quite a lot, huh?
Yes, that's fine. I'm happy to go through all these aspects.
Thank you very much, Dr. Jaye. So, what are your full names?
My name is Assan, A-S-S-A-N. Jaye is the surname. Most people confuse it to GAYE, but Jaye is nicer than GAYE. So it's J-A-Y-E, Jaye.
I would endorse that, but Dr. Jaye, sit comfortably.
Okay.
This may be a marathon session.
All right, that's
so
fine.
relax and.
I think I have the endurance.
Thank you very much.
Yes.
Thank you very much. Good. So, Dr. Assan Jaye, can you briefly tell us about your educational background?
Okay. Initially, I studied as a veterinarian. I did my veterinary education in Nigeria, where I got my Doctor of Veterinary Medicine degree in 1988. And then at that time, I wondered whether I should actually practice, which was my major ambition, to practice veterinary medicine and become a major farmer, or to be a researcher. But I was convinced by my external examiner to be a researcher. So I luckily got a scholarship immediately to go and do a PhD to specialize in immunology and molecular biology. At that time, it was genetics. And I did my PhD, registered at Brunel University, but I did much of my research work in Kenya. So commuting between Kenya and Kenya and UK. There was an international research center there. So I worked on immunology of trypanosomes, which is a major infection in cattle, and molecular biology, genetics, and made some discovery there for the PhD anyway. But after the PhD, I then got recruited, got a fellowship, postdoctoral fellowship with the MRC then in 1993, when I joined the MRC as a postdoc fellow, and started working on the immunology, because they wanted to explore my expertise in immunology to study viral infections. At that time, there was a measles outbreak, and we did quite a good number of studies there about measles outbreak in the Gambia and how the body responds to it. And I then proceeded, after 5 years, we got good publications out of that, and then moved on to study HIV infection.
Dr. Jaye, perhaps maybe we should take it a little more slowly,
okay,
so that the commissioners and the audience would digest the information.
Okay.
Because this is information overload. and may I also apologize, Mr. Chair, for the lack of interpretation at this stage, because it would be mighty difficult to interpret this in any of the local languages. So perhaps maybe when we go to the gist of the issues, we would have an interpretation in Wolof. Not, of course, for Dr. Jaye, but for the audience that is listening at home.
Okay.
Proceed, please.
Yeah, so I did a lot of work. I mean, I moved from my research from measles to HIV infection, and then set up the measles immunology group, and we became eventually one of the strongest HIV immunology group in the whole world. The reason was because in the Gambia, we had the opportunity to have two kinds of infection, both HIV-1 and HIV-2 infection. And the HIV-2 infection was a bit rare in other countries, except in the Portuguese colonies, such as Guinea-Bissau and others. And so we developed a cohort, a very sizable good cohort of HIV-2 and HIV-1 infection in the Gambia and in Guinea-Bissau. The reason was that the HIV-2 infected individuals are long-term non-progressors, and we wanted to understand why these people are not as affected as HIV-1. Okay.
But this major breakthrough discovery was done in Gambia.
These studies were done in the Gambia, and discoveries where we had actually identified that there were certain components of the immune system that are responsible to fight initially against HIV were discovered in the Gambia. And our group, because we had that comparative, that advantage to compare an infection that do not progress well with an infection that progresses, we had that opportunity. We were able to inform those who work in HIV-1 in other parts of the world about what is really happening in terms of the immune reactions. And by the way, about the qualification, I think one of the reasons why I was elected as the first government to be elected in the African Academy of Sciences was because of such a work we were doing. So I became a fellow of the African Academy of Sciences.
Congratulations. The first Gambian to be elected in that body. It's quite a lofty achievement. But you did not only register that kind of success in research, even your undergraduate studies, you did receive a number of awards, didn't you?
Yes, that was the reason why I was immediately offered this prestigious scholarship to do PhD, because my external examiner felt this was exceptional. And yes, during my Doctor of Veterinary Medicine degree, I continued to receive, during my period of that course, I continued to receive awards and prizes, academic prizes.
But apart from all that, you occupied important positions at your place of work at the MRC.
Yes, I started as a postdoctoral fellow. Out of the good work that we did in measles, I was promoted to become a senior postdoctoral fellow. And then for another 3 years. And then after that...
And that position was funded by?
That position was funded by Rockefeller.
The Rockefeller Foundation. That's right.
And then after that period, when we successfully worked on measles and produced some good results, and one of the important outcome of that work in measles was actually to show WHO was actually recommending 9 months, and you cannot vaccinate again, or you cannot vaccinate before 9 months of measles. And we wanted to prove that it's possible. And I had to do some, I don't want to go into the scientific details, but we had to go through certain real rigorous laboratory work to prove that, the passive immunity does not, is important, but does not prevent a revaccination. So we published this, and now that became also an information for the WHO to say, to build herd immunity, you can actually do a 2-dose vaccination in Africa. And that's why where there are outbreaks like currently in DRC, I think in Congo, they are now trying to do double-dose vaccination despite the 9 months schedule.
And that was as a result of the success of your research?
That was as a result of our work, and the publication is actually indicated in the CV.
That's right.
Yeah.
So as a result of that, you got promoted?
I then became an international scientist. Appointed directly by the MRC office in UK as an international scientist.
The MRC office in UK is part of the London School of Hygiene and Tropical Medicine.
That became recent. During this period I was working, it was independent. It was basically run and funded by, it was funded but also oversight administered by the Medical Research Council in UK.
In the UK.
It's just about 2 years ago that MRC UK decided to merge us with the London School of Hygiene and Tropical Medicine, and now we are part and parcel of London School of Hygiene and Tropical Medicine.
And that is, well, it just speaks volumes about the credibility of MRC.
Exactly, exactly.
Thank you very much. So in 1998, you became a scientist specializing in immunology.
Yeah.
And you became in charge of HIV and measles immunology.
Yes.
And after that, what did you do? Let's talk about your career progressions, and then we would come to other aspects of your work.
During that period, actually, my major interest was really to understand why people in HIV to infected those who are infected with HIV-2, why they don't progress as fast as HIV-1. And I don't know whether you want me to the differences between this infection.
We would come to that at a later stage, because we would want to examine how you progressed in HIV treatment in the Gambia and what was the ultimate objective to phase it out completely from
but to understand the treatment issue, we need to I just need to introduce really some aspects of the HIV itself.
Please go ahead.
HIV virus, as you know, as you're asking about my progression there in research, the HIV virus, people have to understand that it was discovered in 1980 or 81, around there at that time. And it's a virus that is special. It's in the family of retroviruses, but it's a special retroviruses in the lentiviruses because it has a two positive strand RNA in its genome. And it jumped from chimpanzee. For the HIV-1, it jumped from chimpanzee to humans, whereas the HIV-2 jumped from Sooty-Mangabe monkeys to humans. Now, it was believed that this chimpanzee one originated from Central Africa, and the Sooty-Mangabe SIV, simian immunodeficiency virus, which is its origin, jumped from monkeys to humans in Guinea-Bissau. And that's why when during the Portuguese War and the exchange of soldiers, that's why the HIV-2 became very spread in the Portuguese colonies through that. Now, this work on molecular clock actually confirmed that this jumping started in 1931 for HIV-1, jumping from chimpanzee to humans, whereas HIV-2 was about 1940. But that's the history of it. And the thing about the HIV-2, why it is special, is because the two RNAs have the capacity to integrate itself into the human's DNA itself.
This is very interesting because this is at the heart of the issue whether there can be a cure for HIV,
exactly,
or what you can only have is treatment.
Exactly.
But let's go back to your qualifications.
Yes.
I just want to show how much of an expert you are in this area. Yes. I know you're much more excited talking about the technical issues than really showing your qualifications, but we have to go through this.
Okay, no problem.
All right.
Yes. Okay.
So in August 2008 to January 2011, you became the interim head for the viral diseases program at MRC, correct?
Yes, yes.
And in January 2011 to March 2016, you became, you were senior scientist and head of HIV research, the West Africa collaboration, and you were seconded to Laboratory of Bacteriology and Virology
yes,
at Cheikh Anta Diop University in Dakar, Senegal.
Yes.
So pretty much, for most of your career, you are a researcher on immunology.
That's right.
And you've made quite a number of publications in this particular area, haven't you?
Yes.
You have a copy of your CV, yes. Could you take a look at it? And give us a brief rundown of the publications that you have made. I know that looking at the CV, it's by the way, Mr. Chair, it's about a 13-page CV, 12 pages. You've made about 85 publications in international journals.
That's right.
Could you just run us through just a selection of the publications? We would exhibit your CV. Just give us a brief run-through of some of them.
Of some of them, okay. Initially, on the measles vaccine, on the measles work, you could see that publication 5 and publication 6, where I was the first author, they were really showing good work on how the responses are when you get infected measles. But publication 6 for that was a very difficult journal to get published in. Only very, very high quality science goes into this journal. So for
what's
HIV,
the name of the journal?
Clinical Journal, Journal of Clinical Investigation.
Okay.
If you'll be a very lucky scientist to get a publication in this journal. So, but for the HIV itself, actually it flows from publication 9 to, onwards, But if I give specific examples of where we really made good inroads and provided information internationally, would be publication 17, where, first of all, we discovered that the quantity of responses between the two infections are the same. But the ones that later confirmed, that also informed the international community was where we looked at quality of responses, and publication 23, where the first author was my PhD student, published another arm of the immune response to HIV-1 that shows a quality of immune response in HIV-2 different from HIV-1. And it also follows in 25, the same kind of, similar kind of work that really showed that there is some quality of responses in HIV-2 that can inform HIV-1 vaccine development. That's also my PhD student. And it follows similarly into 26, 20, 30, publication 30, and also 32. All these ones were work that we vigorously did here to really show, to inform the world about the nature of the immune responses to HIV infection.
And that was published in the European Journal of Immunology?
Yes, exactly.
Proceed, please.
Yeah, so it goes on like that, actually. I don't know whether I should really give, but, there's quite a number of the publications that are, and in terms of treatment and resistance, multi-drug resistance issues in HIV, publication 37 was done by one of my students also there in page 37, and also 36, where it shows the responses of the heart in the HIV-1, HIV-2 dually infected patients in the Gambia, and the emergence of drug resistance. We published that in Journal of Clinical Microbiology, and a student who is a Gambian PhD student there did that work under my supervision. And equally, we've published the nature of the virus in HIV-2 itself structurally, and that's publication 39. We also wanted to understand what is the quality of the function of the response when you are co-infected with TB, and that publication is reflected in page 44. Yeah. So there are some epidemiological studies we did to really understand the natural cause of the infections in both Guinea-Bissau and the Gambia, and that's reflected in publication 47. And I was particularly also interested because I set up the genetics lab, we call the HLA lab, Human Leukocyte Antigen typing lab. We wanted to understand the influence of the genetics to the response of HIV, and a student of mine did some work there to show the influence of HLA class 1 and genotypes for HIV, on HIV-1, 2 infections, to see whether that influences the progression. And that you could see in publication 48 by the, so I don't know whether I should continue because the list is so long, and I thought I wanted some examples.
We want to appreciate the extent of your involvement in research in this area.
Yeah.
We want to know the extent of your expertise in this area.
Yes.
We want to know we want to have a good foundation upon which we would evaluate the opinions that you are going to offer to this commission.
Yeah. So yeah, no, certainly it's all given by the quality and the variability of the kind of scientific work we've done, including the immunology, including the genetics, including epidemiology, and also including clinical treatment and of both HIV and co-infections. And you know, it's all reflected in the various publications listed here.
And Dr. Jaye, these publications are in the most valued medical journals in the world.
Yes, these are all internationally recognized medical journals where it's peer-reviewed. It's that's one of the difficulties in research career is, you know, getting your work accepted in a publication. It's a challenge. You don't just submit and get it accepted. It's peer-reviewed, and the criticism, sometimes you go through lots of problems before these papers are accepted. And the published journals are ranked into qualities, they call them impact factors. And all these journals, most of, or 3/4 of these journals are actually at a very high impact factor.
Yes. And you have published about 85.
Exactly.
But besides, apart from publications, you have supervised researchers at the highest levels.
Yes.
Could you give us a few examples?
The number of students I've supervised?
Yes.
I think I've listed them in my publications. It is so many. I have supervised a Gambian for master's program at Ulcers called Jibulba. I've supervised Louis Murray for a master's program. I've supervised Victor Nuvo, a Ghanaian, for PhD, which he submitted in 2009. I supervised Abdurrahman Haman from Ghana on an MPhil program and worked on mycobacterial antigens, and in 2008, I supervised Irfan Zaidi, who was from Pakistan, and he worked on HIV-2 Trrc infections, and he submitted his PhD in 2013. I supervised Alberta Davis, a PhD student who is a Gambian, doing a PhD, currently actually still doing her PhD. I've also mentored and supervised Dr. Sabal Jallo, who is now a postdoc working in South Africa. I'm still her mentor. I was an advisor in the PhD. I supervised the masters. I mentored Dr. John McNamee from UK. I also mentored Dr. Odwok when she was in the clinic working on a treatment of HIV, and Dr. Togun, who is currently a postdoc in London, at the London School in London. I mentored him when he was a physician responsible for treating the HIV patients. And Dr. Mustafa Mbow from Senegal, I'm still his mentor, and we recently, just 3 weeks ago, published one paper in Science. He's a Senegalese, and he's a postdoc working at Anta Diop University. Dr. Musa Cham also is a postdoc who is my mentee, and still in Senegal working on HIV infections. So these are some of the, I wouldn't listed the others that I'm a co-supervisor, but these are the ones I directly supervised.
But you're also a member of several high-profile committees, such as the Association of University Teachers in the UK.
Yes.
You are also a member of the Royal Society of Tropical Medicine and Hygiene. You're also a member of the Gambia Vets Association.
Yes.
The Gambia Immunology Society.
Yes.
You are a board member
I'm
of the board
actually the chair. I'm the president of the Gambia Immunology Society.
Fantastic. West Africa Livestock Innovation Center, you're also a member?
I'm a member of the council.
Yes. And a board member of schools and so forth.
Yeah.
Okay. It's a very fat CV, Mr. Chair. I just ask that we put it in, we exhibit it, and the commissioners will take a look at it later if they are interested. But clearly, it shows the depth of knowledge, extent of experience that Dr. Jaye has in this area. Mr. Chair, I had asked that the copy be circulated to all commissioners so that they can follow as we progress. I wonder whether you have it before you. Okay. I ask that it be given exhibit number 157 if it is accepted, Mr. Chair.
Request granted, Council.
Thank you very much. Dr. Jaye, wealth of experience in immunology. Now kindly give us a brief history of the discovery of HIV. I know you've told us how HIV-1 has mutated from chimpanzees around the Congo and HIV-2 from monkeys in Guinea-Bissau in 1931 or thereabout, and ultimately their discovery in 1981. Could you please take it from there, please?
Shortly after the discovery of HIV in 81 in the whole world, which became really a global epidemic, Gambia discovered some individuals with HIV through epidemiological surveys that they've done. I hadn't then started work on that because I was around 83. So it was clearly very early done by one of my mentors, Professor Hilton Whittle, who's now retired, who really started it. They built up a cohort in Guinea-Bissau, small cohort. They realized the HIV-2 was really there, but then was also in the Gambia. And I joined in 1993 when that cohort was beginning to develop. We then developed a cohort after I joined the HIV group in 1998, after following my measles work. We developed the cohort, which grew up to about 1,600, comprising of about 800 HIV-1 and 450 HIV-2, and the rest were dual infected people. Dual infected people means being infected by both HIV-1 and HIV-2.
During this period, could you just give us a brief rundown of the discovery of medicines for HIV treatment?
Yes, so initially, as I said in 83, the only work, we confined our work to understand the prevalence of these infections in the Gambia and how problematic it would be. Then following the setup of the immunology group, treatment just started when the first drug was discovered, I think around 1987. And the first drug that was discovered was called AZT in short. This is zidovudine. And this was the first drug. And when it started, we immediately started using the drug for HIV-infected individuals. Yeah? But at that time, it was just a clinical use. It was found not to be quite effective, the single drug, because what happened is that there was quite a good mutation. And let me just go back and say the two major problems of HIV is because I mentioned about the ability to integrate into the DNA. But if it integrates into the DNA, it has that ability to hide itself, for a long period. And that's the reason why it's always one step ahead of the immune response of the body itself, the soldiers. The soldiers responsible for doing the surveillance and attacking. And the second thing is that when it comes out in bits. It has the ability to mutate. Mutate means it changes some of its sequences. So when you give a drug and recognize a drug, it tells other parts of him to say, go back and hide. And then when it comes back, it will have changed some of its sequences that the drug will not be able to attack. And so that single drug was ineffective because of that.
But before this single drug, HIV was basically a death sentence.
It was a death sentence. It was a death sentence, and when even that drug came, it was still a death sentence because of these problems that I'm now alluding to. And that's why I want you to understand that the major problems of HIV, which to some extent is still existing. Now, beside that changing itself, it has the capacity to multiply at a very high rate, but with that multiplication, it always changes its sequence, because what really dictates its multiplication is called a transcriptase enzyme, which actually makes it to multiply. But then the way it's doing that is error-prone, and that's why it's easily able to mutate and change. And so that high diversity becomes an issue in HIV. So I just want to mention why the treatment is a problem, because of those factors and that capability that HIV has. Now, yes.
And because it was so difficult to treat, it was a death sentence.
It was a death sentence.
Everybody was scared of it.
Everybody was scared of HIV. And once you get it, you just think that, I mean, the chances for you to die is very high. And even with the Zidovudine discovery.
But because it was a sexually transmitted disease, the stigma attached to it was also very high.
Very high.
And this resulted in this dual problem of contracting a sexually transmitted disease that was definitely going to kill the person.
Yes. Yes.
That created a problem.
That created a problem. So, few years later, and this zidovudine is under the class of what they call nucleoside reverse transcriptase inhibitors, because these drugs, what they do is that the virus depends on some enzymes to integrate and also to multiply. And these enzymes are called reverse transcriptase. Then there's the protease, which enables it to, to also get that machinery of the host cells to multiply. There's the integrase enzyme as well. So these drugs are designed to inhibit these enzymes. Now, zidovudine, inhibiting the transcriptase enzyme so that it will multiply, was not quite efficient enough, because the virus can have an escape route to multiply. Then all the drugs came later to be discovered in the same class of nucleoside reverse transcriptase. And one of them is called Trrc or lamivudine. Now then and that was where our first trial came, our first treatment trial came, when the second drug was discovered, lamivudine. So we thought, and that was what was recommended then, that if perhaps we combine the two drugs, it will help, it will help the patients to a level that there will be mutations and, drug resistance. We then did what is known as the viral turnover studies. I think it was around 1998, if I remember, when we started that, to do this two combination of drugs. But they are the same class in the nucleoside reverse transcriptase class, and they call it Combivir. We did a trial that was approved by the Gambia Ethics, Joint Gambia MRC Ethics Committee, because any research you do in this country, including clinical trial, has to be first approved by the ethics committee in this country.
Why is that the case?
Because there is no research, medical research internationally, that's supposed to be done anywhere in the world without approval from an ethics committee. And the ethics committee's role is to protect the patient, not the researcher. So they have to look at the ethical issues. are these how you give the drugs, how you follow these patients, and what are the actual methodologies you use, and how are you disadvantaging the patients you've recruited, and what is the recruitment procedures, and whether these patients have given informed consent. These are the ethics issues that any ethics committee must scrutinize and look at properly before they give approval.
It looks to me that the entire practice of medicine is anchored on some significant ethical considerations.
No, yes, but not the treatment, not medical practice and treatment. No, you don't have to have ethical approval for that. Routine medical data and clinical routine treatment, you don't. But research, research and clinical trial, you must get an ethical approval.
That is understood. But my question is even broader, that my proposition is that the entire practice of medicine is anchored on some strong ethical foundation, which should always be observed by the practitioners, be it research or actual practice.
That is true. That is true.
At this stage, could we have interpretation in Wolof for what can be interpreted? And or we just proceed in English? Because I'm wondering how much of this could be interpreted in Wolof.
That's the problem.
So we proceed in English. Mr. Chair,
there are some
advice?
things that may be technically difficult to interpret, but I mean, it's up to you.
Mr. Chair, what is your advice?
Council, I think the point that you raised at the beginning, that at some point a summary or some idea be given as to what Dr. Jaye has indicated would be the best way to go about it. A simultaneous interpretation may be a bit complicated. We have excellent interpreters, and they've been very, very helpful in interpreting some complicated principles, but I think for the moment we should continue the exchange between the two of you in English.
Thank you very much, Mr. Chair. I was really flabbergasted when I heard Nyankong Korong interpretation. That was my first exposure to that word. So I could imagine interpreting bacteriology and all that in English. It would be crazy. So we proceed in English, Mr. Chair. Thank you very much. So Dr. Jaye.
I was at the level of the viral turnover study we did because of the two drugs that finally came. The second drug of the first class that came, and we combined the two. Now, we did that study recruiting about 14 people in our cohort to try and see what we wanted to see is how effective is this, and what are the clinical changes that would happen when you give this, how often would they get this resistance. By and large, it was a good treatment that went in, but it was suboptimal. But luckily,
what do you mean by it was suboptimal?
It was suboptimal in the sense that eventually some of the patients we recruited, had, drug resistance. They were become resistant to the drug, and there was mutation. So, but luckily, following that, and that was the time, I must emphasize that during that time, when there was this only class of drug, there was a time when clinicians had a very difficult moment or difficult moments to really manage HIV, because it has to be accompanied with good counseling, with advice on adherence, and with follow-ups. And what MRC did for its cohorts was to recruit many field workers and train them how to interact with these people and how to do the follow-up for them to give support, both in terms of nutritional support, in terms of counseling, etc. So because it was the most difficult moment, you want to try and help them to combat infection, especially those who were progressing to stage 3 or stage 4. There wasn't a problem for the asymptomatic ones. But for those progressing to stage 3 to stage 4, we needed to really have a good surveillance on them. And we at our own expense, were following this cohort regularly and doing the monitoring. So every 3 months we have to collect samples to monitor their CD4 count and also their viral load, which at that time was very expensive to do. But we had to do it because we were obliged to really do, because we've already ethically been approved to work on, to do research on these people. So we are mandated also to take care of them.
Did you have the facilities to do those tests on viral loads?
We had the facilities, Actually at that time, the only place in the country that could do the viral load, because we developed our own in-house viral load assessment through RT, what is called reverse transcriptase PCR mechanism based on certain primers that are selected, and we could detect, through this methodology, molecular methodology, the viral load for both HIV plasma viral load for both HIV1 and HIV2. And when you treat and you don't get detectable viral loads, like in HIV2, we did not even need treatment at that time. You could have, you may have low or undetectable viral load, but we have a capacity to also detect what is known as proviral load. And proviral load is the DNA itself in the cells, which if you take out, and you will still see. And this is important. It's important in the sense that I think when you come to that in the PAP presidential treatment, whether that proviral load was done to ensure that the actual viral was still there or not. I don't think it was. But I'm just mentioning because this is important. They always say viral load. But viral load are 2 forms. The plasma viral load, which is the particles that are released in the bloodstream, and that you can measure, or any lab can, or some of the labs can measure internationally, and including ours, but there is also the aspect to really know, and this is where we know that it's very difficult to eliminate and treat HIV, kill HIV. When you really do the proviral load DNA test, you will still see positivity there, suggesting the virus is still there. Now we had the capacity to do all those, and then do the CD4 counts as well, and do that monitoring follow-up. So we continue with that cohort for the monitoring, for that treatment. Now, coming back to the treatment issues, I think it was about 2000 when a second class of drug came, and this is called the non-nucleoside reverse transcriptase class, including nevirapine, and Caletra, which is ritonavir and lopinavir. And these were classes that were, and also they included the protease inhibitors, that's the ritonavir, and the D40, which is tavudine. And these were drugs that came under 2 different classes. And then WHO came with a guideline that we should try to prevent these frequent mutations and potential drug resistance that could come. If we combine drugs from these 2 classes, we will achieve a delayed replication. And once we achieve delayed replication, the mutation would not happen. And then clinicians started trying that, and we tried it too. We started using 2 classes, 2 drugs from at least 2 to 3 drugs from at least 2 classes. And then when we did that combination, that became the game changer, not only for our unit, but for everywhere in the world, actually. And this is what we call HART.
What do you mean by it became a game changer?
It became a game changer because the moment these 2 drug combinations were given, these combinations of drugs from 2 classes were given, it was able to quickly suppress the viral replication. But not only that, if you maintain the therapy with a good adherence, the viral replication becomes so low that transmission doesn't happen again. There won't be enough in the plasma for the plasma viral load to effect transmission. And this was when now HIV declared that it's a manageable infection. And it then turned out to become a disease that can be managed like any chronic infection. Like diabetes, you stay with the drugs for the rest of your life and have a productive life. And that is what we came to discover with these new classes of drugs.
Essentially, what was very likely a death sentence have now been reduced by reason of medicine to a disease that you can live with for a very, very long time.
With a very good productive life and a good quality of life.
For as long as you take your medicine.
For as long as you are adherent to your medicine.
So it just became just like diabetes.
Exactly.
Like any other.
Exactly.
Yeah.
And consequently, after trying these drugs for about a decade now, and that's why people wonder why is HIV not talked about anymore. Even though we don't have a vaccine, and maybe I could come to why it's difficult to really produce a vaccine, but I'm not sure it's necessary now. But people will now say, why don't we talk about HIV? But this is the major reason. The major reason that it became an infection, surprisingly, because HIV is the first known successful virus. When a virus is regarded successful, it's because it's able to maintain itself in its host. Unlike Ebola kills you and kills itself and then disappears. So it's not a successful virus, but it's very deadly. But HIV becomes chronic and maintains itself, and that's why it's a successful virus. And once you get that kind of virus, you have a problem. And that's why HIV became a problem. But now with this thorough research and phenomenally, exceptionally high quality and high quantity of research worldwide, these measures, intervention measures came into being. And now HIV becomes controlled, manageable, that people are now living a productive life for very long periods in their lives.
And you was telling us that that type of treatment, this combination of drugs that are used, is the highly active antiretroviral therapy.
In short,
which is what you call HART.
That's right.
And this represented a game changer in HIV treatment.
Absolutely.
So from then onwards, HIV was no longer that big, gigantic problem which everybody was scared of because it was a death sentence.
Exactly, and that's the reason why some people, that was why Kofi Annan was able to really convince some big funders to really provide money and that's how the Global Fund came into being, to really supply drugs so that they could actually manage this disease in poor countries like Africa.
Tell us, what was the long-term expected impact of using HART? Because from what I understand, it manages to significantly reduce viral loads on the person to the extent that it cannot be, the disease can no longer be transmitted to another person. Yeah, yeah. So eventually, it would eliminate HIV almost to a very, very small scale.
Yes, I will say it will eliminate, because elimination can mean, scientifically can mean something different. But I would say its use has controlled HIV. I would say it's controlled it to a very considerable degree. Many epidemiological research studies after these multiple drug interventions have been carried out in various groups to really show to what extent there's an impact on this intervention, whether you would really have a resurgence, how quickly do you have a resurgence, how quickly can you have mutations against this, and what are they? Then there were some results where you could have resurgence, you could have mutations coming against them for certain types of, HIV has various types because of the mutations I was saying. And then there came what is known as second-line therapy. So clinicians can bring in a second-line therapy where you can actually circumvent the long-term effects of viruses that involve Dendigarbopa. This is the type that are say, look, I'm just going to make sure, I survive this in this person, and then they will come up. And then consequently more drugs came, and there were more combinations and second line changing, and it becomes, as you said, becomes like diabetes. And not only that, the viral loads get so low that there won't be transmission in the community. And that is really what the game changer means.
Exactly.
And so the epidemic becomes an issue. I mean, if I can maybe say, now the recent thing is actually, because of the discovery of these drugs, the recent thing is now trying to implement even what is known as PrEP for very highly vulnerable people, such as those sex workers and men who have sex with men, to give what is known as PrEP. PrEP is pre-exposure prophylaxis. And why that? Because the new drug is just recently discovered called cabotegravir, which is, when you give, it has a long-term effect. When you inject it, it has a long-term effect. So when you give it for every 3 months or 4 months, even if you are exposed by somebody who is a viral spreader, you don't get infected. So this is how the treatment has evolved now to really manage HIV.
In a sense, the available treatment for HIV had so significantly advanced that the biggest problems for the world of medicine is no longer HIV.
Absolutely.
So it's other things.
Absolutely.
But this heart treatment, it became available in Gambia, wasn't it?
Yes, it became available shortly after it was proven, I think 2004, around there, where it started available. And as I said, when the Global Fund got established, this facilitated the funding, to African governments so that there will be free access of these drugs.
So pretty much the medication became available for free for people in Gambia who are infected by HIV and AIDS.
Yes.
How were these people? What were the steps taken by MRC to admit these people, to give them access to the heart treatment program?
Yes, well, that's an important question, because we had developed the protocol even long before the heart came in. As I said, alluded to when we started the first treatment trial, starting with the initial drugs. Because they are in the cohort, they've consented to be followed up and to be looked after. We will counsel them on the treatment, but basically, one of the most essential part of this procedure is adherence counseling, because the moment you don't adhere to the drug regimens, you're likely to fail. You as a clinician who is managing, but the patient also will be in jeopardy. So the counseling is there, but then we will also make them accept monitoring, because no matter how we have confidence that these drugs work, we need to monitor them. And so we develop a clinical database where we will monitor each of the patients that will come into drug. But during that time, there was only some special category that will be enrolled for treatment. The asymptomatic in the cohorts, and asymptomatics are the one in stage 1, and asymptomatic is only maybe those who have antibody positive, maybe occasional lymphadenopathy, but are not having good CD4 count, because we monitor all the members of the cohort anyway for CD4 count. If you have high CD4 count, we won't treat you. The reason why you are not treated is because at that time, it was scientifically proven that those who are asymptomatic have still a strong immune response and could inherently be fighting well with the virus. And if the drugs can actually make them a little bit weak, to hamper that ability to fight the drug. So we don't treat them, we continue to monitor them. Whereas those who come into stage 3, where they have an unexplained gain loss, weight loss of more than 10% of your presumed or measured body weight with recurrent viral infections and potential recurrent diarrhea and co-infections. These stage 3, stage 4 most likely will have a CD4 count of at 200 per microliter. And then these people will be starting treatment, but we don't start them immediately. There was a committee that was set up in collaboration with Gambia, with the Gambia government. I think it was the 8th Secretariat and the CCM, the country coordinating mechanisms through which the Global Fund is administered, I think, at that time. I don't know what is the procedures now, but there was what is known Treatment Eligibility Committee that was created in collaboration with MRC. And these patients who will be selected for treatment because of these parameters, clinical parameters we've observed, will be vetted by the committee before they start the treatment. And then we will start the treatment based on that, but proper counseling, proper adherence advice, and then explanation of the procedures for monitoring CD4 count and viral load.
In a sense, you had to go through all the elements of your established protocol.
Exactly.
Counseling, adherence, screening, advice on opportunistic infections,
yes,
social and nutritional
support
before you actually
before we start. So we will gather all the clinical parameters that are essential that will help in the management and in the monitoring of that treatment you're doing for each individual patient.
In a sense, you would have to gather all the baseline data that is needed before a person is admitted into the program.
Exactly.
All right. At this stage, you've talked about the various stages of HIV. It would be important also for the Commission to have an understanding of the differences between HIV and AIDS. Could you give us that explanation?
Oh yeah, that's right. HIV, if you say you are HIV infected, doesn't necessarily mean you are having AIDS. You can be HIV infected and you don't have AIDS. The difference is that HIV infection comes in 4 stages clinically, and this is, you Google WHO clinical guidelines, you will see them. The first stage is called stage 1, where it is where the person is asymptomatic, doesn't have symptoms, but there can be what is known as lymphadenopathy. That's most likely what you would observe. Lymphadenopathy is enlargement of some of the lymph nodes. That's most likely what you may observe. Some you don't even, and they will just be asymptomatic. How do you know they are asymptomatic? They perhaps had an occasional infection here and there, or visit a clinic here and there to complain something, and you happen to test HIV, and then they were positive by antibody. And these people can remain asymptomatic for a period of 3 to 10 years if it is HIV-1, before their CD4 count starts getting affected. In the case of HIV-2, they can remain in that period of asymptomatic for up to 20 years.
Is that the reason why it is said that you can see a seemingly healthy person who is HIV positive?
Absolutely. Absolutely, that's the reason. Because once you get HIV, then in fact you may not just immediately calm down. The body also is constituted in a way that can really fight infections. Despite that, HIV attacks one of the frontline soldiers. And the way the body fights is because, I don't know who designed an army, the way army works, but he may perhaps be an immunologist who did that, but it's exactly that's the way immunology works. You have surveillance system, you have a navy, here you have something in the blood that really looks out for something strange, and you have different divisions of different soldiers within the body who has specific roles to play. And this is exactly what the body does when infection comes in. But it's now up to the virus to say how best I'll be tricky enough to overwhelm these people, these different soldiers, or I'll, allow them to fight me. So this is how it works. So stage 1 is like that with an asymptomatic period. Then the stage 2 is where now the infection starts coming in. It's still not AIDS, but you start having more recurrent respiratory infections because the respiration, and perhaps maybe even digestive infections, so that and that will result to diarrhea. The reason is there are lots of microbes in the around areas and also in the digestive tract. And once immunity starts falling down, this bacteria also turns against you. And that's the reason why you now start getting those kind of infections. But you may not be having AIDS because your CD4 counts are still strong enough. They're still not below 350. It is stage 3 where the CD4 counts have really gone down, and there is an explainable weight loss of more than 10% of your presumed or measured body weight, where you're losing considerable weight and accompanied by severe diarrhea and co-infections happening, etc. And the stage 4 is what is known as HIV wasting. That's when you see a person and know that this person is really, really sick because it's completely emaciated. And potentially, if you do other infections, it may have concurrent TB or hepatitis B or other co-infections. That's the stage 4, and that's AIDS. 3 and 4 are potentially the AIDS defining, clinical stages. So this is the difference.
But in Gambia, with the protocol that was established, especially the relationship that existed between the members of the cohort and those who are responsible for treating it, you were able to really deal with the situation successfully. Was that the case?
That's the case. Majority of them were treatment success. We had successful treatment. Who you would call treatment success. Treatment failures can happen once in a while in some patients due to one reason or another. Clinically, that can be clinically of a reason. But majority of them were successfully treated and virus suppressed. And those who were towards the stage of 3 and 4 will revert back to behave like stage 1 and 2.
And with all this, you help assist to establish support groups amongst members of the community who were infected. Can you tell us about that?
Yes, apparently it was important to give confidence and more trust, engender trust between doctors and who are managing these infections and patients, but also to create some kind of a peer-to-peer support. And one of the phenomenal good things that really happened eventually was the creation of the Santa Yala group. That came into being, and one of our doctors was highly engaged in that, or one or two actually of our medical clinical doctors was, as I said, I became just the head of the viral disease program and having an oversight management of it, but the real frontline people working with these guys were the clinicians then under my department, and they used to do phenomenal work to establish that trust and relationship. And the creation of the Santa Yala group, which is the HIV-infected people coming together as a group, I think was fantastic. It really helped the nutritional support, helped the adherence process and everything.
In fact, in your statement at paragraph 10, you said as follows, and I quote, MRC Gambia had a HIV cohort of 1,600 HIV-1 infected individuals as up to 2005. These were clinically taken by MRC HIV clinical staff. Clinical visits would entail monitoring CD4 count, plasma viral load testing, counseling, adherence if on therapy, and periodic field worker visits. There was good relationship between field workers and patients to a level where we encourage support groups. The patients created one support group called Santayala, where there are peer support and nutritional support within them. This is the crux of it.
Yeah.
This was how we were managing HIV in Gambia, to the extent that 90% of the patients had suppressed viral loads with increased CD4 count.
Exactly.
And were doing very well.
Exactly. That's quite right. That's quite right. The treatment was no doubt very successful.
Was there any need to change our approach?
Absolutely not. Not that I see, or not that any scientist would see. Because whatever approach you do has to be based on scientific evidence.
And for those who were not eligible for treatment because they were maybe stage 1, according to your statement, you followed them in your cohort with field workers, and they continued their clinical visits every 3 months.
Exactly.
And during these clinical visits, the array of lab tests were all done, samples were taken, and you made sure that they were okay.
Yes, absolutely.
Still no necessity of other intervention.
Absolutely.
And then, obviously, these drugs that you were using prolonged the lives of those who participated in the program.
Absolutely.
And the effectiveness of these ARVs were not to be doubted at all.
Absolutely.
In fact, in paragraph 12 of your statement, this is what you had to say. It is important to note that once a person gets HIV-1 or dual infection, there is no other treatment other than ARVs, which should be taken for life.
Yep.
That was why we placed so much emphasis on adherence of treatment and field followers, because patients get tired from taking medication every day and no longer want to take it. When patients' viral loads would come up, it would be as a result of drug-resistant mutations, which is triggered by suboptimal intake of the ARVs. We then would have to implement second-line therapy to save the patient.
Exactly.
The multitude choice of drug combinations make it possible to manage HIV patients adequately for them to have long quality of life. Hence, a gigantic step from the days when HIV was regarded as a death sentence.
Exactly.
So the infection became rather a manageable chronic disease, which allows the patient to have a productive life. This was the situation in 2005. Very effective. You guys did a phenomenal job. Then come January 2007, when our president came with his bag of herbs and made a diabolical pronouncement. We will come to that after the break. Thank you, Mr. Chair.
Thank you.
I'd like that point to take the break and then come back to that. But Dr. Jaye, your remark that whatever you do should be based on scientific evidence, and I presume that evidence comes through one door, training and then knowledge, not through intuition. But anyway, we'll get to that when we come back.
Are you addressing Donald Trump?
See what it is. But thank you again. It's a very good setting for our hearings as we get to the next stage. Thank you very much. We'll take a 30-minute break, come back at 12 noon. Thank you. Meeting's adjourned.
Thank you.